Hello students. So we are in a lockdown situation in India. So VTU guided us to create videos for students about our subjects. Okay, no more wasting of time. We'll start. Actually, we have started this multi-threaded programming chapter, right? In this we have already studied multi-threaded programming, what is multi-threaded programming, and what is process-based multitasking, and what is thread-based multitasking, and the differences between this process-based and thread-based already. Okay, so in this chapter we are not studying process-based, we are going for thread-based. Okay, so it is multi-threaded, not multi-process. Okay, so multi-threaded programming. In this we have already studied that what are the different states that a thread will exist: running, ready to run, suspended, resume, blocked, terminated. Okay, all these things already we have studied. Then we have studied about thread priorities, that one thread can have more priority compared to another one. Okay, and all those things we have already studied. Okay, then synchronization, if between two threads if there is no synchronization, they may get wrong information. For example, I have told you that you must prevent one thread from writing data while another thread is in the middle of reading it. That practically we have seen. Ifshar example, I think you remember that one. Now then the thread class contains these many methods and all that we have already studied. So I'm directly jumping to creating a thread. Okay, for creating thread there are two ways. One is you can implement runnable interface, or you can extend a thread class itself. So start with this first one, that is you can implement a runnable interface. Okay, implementing runnable interface. See, runnable is a interface. If you are implementing that interface, means you are going to write the body for the methods which are declared under runnable interface. And see, runnable interface has only one method called run. Okay, so let's start how to implement this runnable interface. Okay, you can construct a thread on any object that implement runnable. Means you can create an object of any class that implements runnable interface. Okay, runnable interface. Now to implement runnable interface, what you need to do is you need to write the body for run method. By declaring like this: public void run, then body of that run method. And in the body of run method we are going to define the code that a thread is going to do. Okay, a code that constitutes the new thread, means what a thread is going to do, that we are writing under the body of run method. Okay, so after you create a class that implements a runnable interface, okay, you will instantiate an object of type thread from within that class. Okay, just remember this point. See that you can create an object of class called thread within a class which is implementing runnable interface. Okay, which is implementing runnable interface. Okay, to create an object, what you need? See, to create an object, what you need to do? You need to just create first. See what you need to do. You need to have a class name, then object name, then is equal to new, then constructor you need, right? You need to have a constructor. So actually this part assigns or creates a new object, right? This part is just a declaring a variable of a class called box. Okay, now this is a constructor. We have already studied about constructors. Now when you are creating the object of a thread class, at that time you need constructors. So the constructor, the thread class provides many constructors. So one that we are going to see in this program, in this example on page number 229, is a constructor name with two parameters that takes first one, a object of a class, see, object of a class which is implementing runnable interface. See here, this is a constructor. Thread object is an instance of a class that is implementing runnable interface, and the second argument is the thread name. See, you cannot simply create a thread without giving name to it. We need to give a name to a thread because to refer it in future. See, if you have a child in your house, you name it, right? See, if you want to call that child, at that time you will refer the name, right? So if you will tell Akif come here, or Sana come here, like this, right? See here, a string thread name, the thread name. The name of the new thread is specified by thread name. After the new thread is created, it will not start running until you call its start method. See, once you have created thread, it will not start automatically. Okay, you need to call that thread. So to start that thread, you need to call a method called start. Start will call, in a sense, start will execute a call to run. Okay, see, remember the points that you need to create a class which is going to implement a runnable interface, and you need to write the body for run method. Okay, and in that class you need to create the object of a class called thread. Okay, then you need to call start will call run. Okay, we'll see a program on page number 229. Okay, program on page number 229. See, in this program, what the author is doing, actually, he is creating a class called new thread, which is implementing runnable interface. Then in that class you need to create the object of a thread class, right? So it is just here, he is just declaring a variable of a thread class. He is not creating an object. Creating object, we'll see. Now what is this actually? This is a constructor, same name as class name, no return type, right? Now this is just a constructor which doesn't have any parameter. Okay, now this constructor is creating a thread object of a thread class. Okay, in this he is using the first constructor that is taking two parameter. In this is a object name which is object of a class which is implementing runnable interface. Means you will say that this is the object, this one is the object of new thread. See how, we'll see. Okay, this is a keyword actually. What I have told you, this will be replaced by the object of a class which is calling this constructor. Okay, we'll see later. Now the second argument was, what was the second argument? Name of the thread. Okay, in this case the name of the thread is demo thread. Name of the thread is demo thread. Okay, now system.out.println. Okay, here you are printing the information about this thread, the child thread, and the information of that child. We'll see in the output what will happen. Okay, what this T will give us. Actually it will give us the priority, the thread name, and under which it is running. Okay, we'll see in the output. So now once you have created, see what are the points. See, you need to implement the runnable interface, you need to create the object of a thread class, then you need to call a start method. Start will call run. Okay, so what you are doing, you are calling start. Okay, so it will call run. In this run you need to write, see, from here to here you need to write what the thread is going to do. So this is the actually opening for run and closing for run, and this is in between this code is for what a thread is doing. Okay, now so what this thread is doing, it is initializing a loop with a I value to 5 and I is greater than 0. Yes, 5 is obviously greater than 0. Then you are decrementing the I value. Then in the first iteration you are printing system.out.println child thread 5, and you are sleeping for, your thread is sleeping for 500 milliseconds. 500 milliseconds means half a second. Half a second. Okay, half a second. So a question that is arising in your mind is why we are having here try and catch. Try and catch because of sleep method. Because of sleep method. Because what the sleep method is, actually how this sleep method was declared is sleep method is public void. See how the sleep method was declared. Public void sleep. Okay, it takes some argument. Okay, it takes some argument, then it throws which exception? This exception, interrupted exception. It throws interrupted exception. Okay, that it doesn't handles. If this method is capable of throwing an exception and that it doesn't handles, then who need to handle it? A code which is going to call sleep. Now we are calling sleep, so we need to handle that interrupted exception. So that's why we are writing this sleep under try and catch. See, this is the open for try, this is the open for loop, and this closes the for loop, this closes the try, and the catch for this sleep. Okay, if any interruption occurs, it will just catch it. Okay, then you are exiting the child. So this class closes over here. Okay, then what we are doing, we are creating here a class called thread demo. In that we are having public static void main. I have told you that main is also a thread. In that main thread we are creating the object of a class called new thread. Means whenever you are creating object of class called new thread, you are calling the constructor of that class. So this is the constructor, and what this constructor is doing, it is creating a thread. Right? Okay, it will create a thread, then it will print the value as, in first iteration value as 5, then it will go for sleep for half a second. During that, maybe main will execute, maybe, because based on scheduling. So main will execute. What the main is doing, the same thing, for loop with I initializes to 5, and same thing, you are printing 5. In first iteration it will print 5, but main is sleeping for 1000 milliseconds, means 1 second. Why this value is greater than this? Because we want main should be closed or terminated at the end. Otherwise you will get unexpected output. If main terminated before the child thread, then you will get unexpected outputs. So that's why we are having here 1000 milliseconds. Okay, so you are calling sleep again, so this should be called under try and a catch. Right, now catch, then main thread exiting. Okay, let me show you the output, how this works. Okay, so we need to create a class called new thread. Okay, in this we need to create a class called new thread. Okay, this is my new thread. Okay, finish. Now let me just fonts, I will increment the size to visible one. Okay, so it will be like 24. It is okay. Yes, new thread. Okay, we have created a class called new thread. Okay, which is implementing now runnable interface. So just copy this code. Let's see the output. See what I have told you already. So what this T will print, it will print the information about the thread that you have created. Let me run this code. See here, child thread, if it is visible, child thread, demo, thread name was what? Thread name was demo thread. So thread name was demo thread, the priority is 5 and it is running under main. So main thread executes first, see here, with a value 5. Then child threads executed 5 and 4, then main thread again, then child thread 3, 2, then main thread, then child thread, then we exited child thread first, then main thread executed 2 and 1, then main thread has executed. Okay. Okay, you got the output. See, in this child thread, then first main thread we have executed. According to this, main thread has executed first. So let me run this again. We'll see that main thread will execute first or child again. Okay, see, let's see. So main is again same output we are getting, same output. It is not necessary that the same output you are getting in your PCs too. Okay, you will get different outputs. Okay. Okay, proceeding further with next slide. Okay, next slide is extending thread. Okay, now the second way. The first way was implementing runnable interface. Now the second way is extending thread class. Okay, now we'll see. The second way to create a thread is to create a new class that extends thread, and then to create an instance of that class. See, what you need to do is you need to create one class that is extending, means this class that you are going to create will be the subclass of thread class. Okay, subclass of thread class. The second way to create a thread is to create a new class that extends threads, means obviously it becomes a subclass of thread class, and then to create an instance of that class, then we need to create of that object of that class. Okay, we'll see. Now the extending class must override run method. Extending class means a class declared by you, which is extending thread class. Okay, in that class you need to override. See, the word is override. Override means the type signature, the number of parameters, the type of parameter, all should be same. Good news is that run will not have any parameters, so you can just write public void run, because it is declared as public void run in thread method. Okay, overriding means you are writing your own body. You are not inheriting the body of thread class. You are writing your own body now, which is the entry point for new thread. Okay, then you need to call start. Start will call run. Okay, we'll see a program on page number 230. Okay, program on page number 230. See, a class which is extending thread, right? So what was the first point? Second way to create a thread is to create a new class that extends thread. Yes, so here you are creating a new class that extends thread. Now in this we have a constructor same name as this class name. Now in this, what you are doing, you are calling your superclass constructor that takes only one parameter, and the parameter is thread name, and the thread name is what? Demo thread. Okay, this super uses we have already seen. Okay, what are you doing? You are printing the information about your child thread, that is system.out.println. This will be replaced by the object who is calling it. See, whenever you are creating the object of that new thread class, so this object reference address will be passed here. Okay, object will be passed here, because this object is now, this class is now threadable. Threadable means what? It is becomes now thread. It becomes now thread. Now because it is extending thread. Now see this. Then start. You are calling start. Start will call run. You need to write, or you need to override run. Okay. Try for, in this for I is equal to 5, I is greater than 0, I minus, same thing. Child is printing 5 in first iteration. Second iteration it will be 4, 3, 2, 1 with a gap of half a second. And we are writing this code under try and catch because of interrupted, because sleep throws interrupted exception that it doesn't handles. Okay, now we are having another class. In that we are having main. So main is creating a thread. See here, object of thread class, new thread, object of new thread. Okay, only the difference between this, see, the difference between this statement and this statement is what? Here we are creating the object and the address we are storing somewhere, means we are storing the address into my box. But here we are just creating the object and we are not storing the address for future reference. Okay, in future you can use this address for lot of works and all. Okay, but here you cannot use that object in future, because after the creation of that object, once it is used here, it is eligible for garbage collection. Okay, now see, when the main is running, what main is doing? The same thing, it is printing 5 with a gap of 1000 milliseconds, means with a gap of 1 second. Okay, the same program but by extending thread. Okay, by extending thread. Let me run this program in NetBeans. I will see the output. Okay, see. Okay, you are getting the same output. So these are the two ways. These are the two ways where you are implementing runnable interface. First way was implementing runnable interface, and next was extending thread class. Okay, so proceeding further, next is what? Creating multiple threads. Creating multiple threads. See, till now what we have done, you have created one thread and a main thread. In main thread you are doing something, and in one thread you are doing something. Suppose you want to create more than one threads, 2 threads, 3 threads, 4 threads. Okay, at that time how to do it? Okay, so what the author is doing is, actually he is following the first way, that is implementing runnable interface in each example. Okay, so we are going to use that method only. Okay, on page number 232, how to create a multiple threads. Okay, so 232, creating multiple threads. See, class new thread implements runnable, same. Then you need to create the object of that thread class. Okay, he is declaring a string name. We'll see what it is. Actually he is giving a hint that name of the thread. We'll see it. Okay, we'll see. What is this? This is the constructor. Now this constructor is using one parameter, and the parameter is what? A thread name. Now you are creating more than one threads, right? So it is taking first thread name, second thread name, third thread name as a parameter, and what it is doing? It is assigning that thread name to a variable called, instance variable called name. This is instance variable and this is a local variable. Okay, instance variable called name. Then that instance variable you are using to create a thread. See, t is equal to new thread, this constructor that you are using. Remember, a constructor which takes two arguments. One is what? A object of a class which is implementing runnable interface, and next one is name of the thread. Okay, now see, this will be replaced by the object of a class which is implementing runnable interface, and name of the thread already you have passed here, that we have already stored in the name. So thread is created. You are printing the information about that thread by attaching that t to the system.out.println. Then you are calling start. Start will call run. Start will call run. And run is doing what? Run is doing what? See, it is printing again 5, 4, 3, 2, 1 for different threads. So this means whenever you are creating first thread is printing 5, 4, 3, 2, 1. Second thread again 5, 4, 3, 2, 1. If you want different bodies, we will have different examples. We'll see it later. Okay. So now all threads body will be same. That first thread, second thread, third thread, fourth thread, whatever that you are going to create. Okay. All threads body will be same. So first thread will print 5, then go for 1 second sleep, then second thread will come into picture, it will print 5, then go into sleep for 1 second, right? 1000 millisecond means 1 second. The same thing. Okay, see, we'll see the main class multithread demo. In that, what we are doing, we are creating a first thread with a name 1. So this is the constructor. We are passing a string as 1. So this will be passed over here. Then it will be assigned to a name, right? Then you are creating a thread. Then you are starting it. So thread 1 is now printing 5, 4, 3, 2, 1, right? With a gap of 1 second. Then again you are creating another thread 2. Then you are creating another thread 3 with a name 3, right? Now, so 1, 2, 3 all are doing the same job, that it is printing. They are printing 5, 4, 3, 2, 1. Okay, with a gap of 1000 milliseconds. What the main is doing again? Main is doing the same thing, waiting for all the threads for 10,000 milliseconds. 10,000 milliseconds means what? 10 seconds. 10,000 milliseconds means 10 seconds. We may expect that within 10 seconds all these three threads will complete its work. Okay, because when one prints 5, at that time it will go to sleep. At that time 2 will come into picture, right? It will print 5, then again it will go to sleep, then 3 will come into picture, it will print 5, right? Within 1 second. See, this is happening within 1 second. So 1 will print, 2 will print, 3 will print. All 3 will go to 1 second. After 1 second again 1, 2, 3, maybe 3, 2, 1, or maybe 2, 1, 3. Okay. Now we'll see, execute this program. We'll execute this program. See here, you'll get different outputs. See the output. See, first thread 1 started 2, 3. So first printed was, who has printed first? 1, then 2, then 3, then 3 again, then 1, then 2, then 2 again, then 3, then 1, then 3, 2, 1, 2, 3. See, the same pattern will not follow. See, we'll see. See, this time different output. See, 1, 3, 2, then 2. See, again if you run 1, 2, 3, 1, 2, 3, 3, 2, 1. See, this is the output. See the output. 1, 2, 3, 1, 2, 3, 3, 2, 1. 1, 3, 2, 3, 2, 1. 3 is exiting, 1 is exiting, 2 is exiting, main thread is executing. Let me execute it again. See, 1, 2, 3, 1, 2, 3, 3, 2, 1, 3, 1, 2, 1, 3, 2, 2 is exiting, 3 is exiting, 1 is exiting, then main will exit. Okay, it's not necessary that you will get the same output in your program, in your system. You will get different outputs. Okay, so this was creating multiple threads. Okay, in next lecture we are going to see is alive and join, thread priorities, synchronization. Okay, up to then, stay home, stay safe. Thank you.